Okay, my name is Dolganov Sergey. I'm from Russia. I live with my wife and 3 dogs, and sometimes I'm a street drummer. Also, I'm working in a company called Evil Martians. We help our customers to deliver product at warp speed, and our tool is open source, actually set of open source tools which we contribute to, which we create on our own, and we also encourage other people to contribute to open source, which we name Cult of Martians. So before we start the actual lecture, or maybe speech, I don't know, I want to ask how many of you actually interested in the topic. Do you actually have as a business domain dependency, some external API? Okay. How many of you have microservices architecture in the application? Okay. And how many of you have front-end and back-end as separate services which just communicate through API? Okay. For all of you, I think the topic will be interesting. For others, don't be upset. I will also cover some general design technique. So let's start. First of all, let's use root cause analysis to cover the topic. The first question is, what do we want? Resilient API dependency. That means that we want it to be safe to use, we want it to be recoverable, and the most important, we want it to be easy to debug. So the next 2 questions are where we have to focus and why. So to answer those questions, let's take a look at the layout of our problem. Anyway, when we can communicate between application and external service, we have to introduce the API client. And from one side of the API client, we have request-response mapping layer, even if we don't actually separate it in our code base. And somewhere, the request-response transportation layer is covered. So this is about actual messages that goes back and forth through the internet, for example. So let's take an example. I have a project called Assert. It's actually an open source tool that measures other open source tools and creates a report about its popularity and maintenance. Inside, I have 4 APIs, like GitHub and Ruby gems, and I have storage per quarter, and the data collection process is non-incremental. What does it mean? Every time I want to update the data about the project, I just wipe out the old one and recreate the whole history. Just because I don't have much time to invest in this project, so the naive solution works well. And at some point, I decided to add Twitter, and from the documentation, I understood that actually I have only access to the last week tweets. Yeah, so that means that per quarter storage will not work. I have to wait at least 12 weeks to have 1 dot in my charts. So that's the problem, and here is our layout. So of course I could use here as an API client some gem, but I have to introduce incremental per week storage, some crutches to make it work with original storage. I have to introduce the fail request recovery and whole mess, just because I wanted to communicate with some external system. As we see, external dependency is not only about communication, but about reflecting the requirements of external system into our business domain. So let's push it forward and assume that every part of the communication could get crazy. So it's not that bad, because actually we could just list them and find treatment for all of them. Let's try the first one. So when we can communicate between the business domain and API client, if we will not filter what's going out and what's going in, we could end up with the mess in the external service and inside our business domain, just because data is could change without any filtration. So if you don't want to feel like that, you have to build not that shitty wall. You have to introduce the some kind of validation between your business domain and the API client. And the best solution for nowadays is using the schema. How many of you actually know about schemas for requests? Oh, okay. Several points about it. So the schema is actually some definition of what fields you expect in the request and in the response, the what field types or just static types maybe you expect, and using the schema, of course, you could validate actual request and response data and understand whether it matches the schema or not. And the OpenAPI initiative is the other iteration of Swagger, who actually you ever heard about Swagger, for the automation of those schemas. So you could write schema in the OpenAPI version, and you automatically will have documentation for your API, and you could generate tests for your API. So pretty cool stuff. But anyway, even if you have OpenAPI inside your application, sometimes you could receive valid from the schema point of view request or response, but invalid data inside that will anyway break your business domain. But we'll cover it later. So first problem is poor boundaries. Move next. Sometimes API clients don't behave the way we expected. So the output that we want to generate for the external service is just something different, maybe because some misunderstanding of the terms that external service use or stuff like that. But anyway, we have to sometimes control the raw HTTP or your protocol request and response to identify if there is a problem with the communication. So to help us, we have, for example, sniffer gem if you use HTTP that will record all the session and log it somewhere, and you will be able to actually fix the problems with them. But sniffer is just logging tool. Of course, it could not make any validation. So if we will have an outage here, we anyway have debug it manually. So this case I will again cover later. So next problem is lost in translation. So next part that could be broken in the communication is that we try to change something in the external service according to our business domain. Let's assume we have some post that we want to publish in the Twitter. We have a record in the database, and we just want this one record to be represented in Twitter as one post. And sometimes happen something like ta-dam and ta-dam. And actually, in those cases, we could not be sure what is the state in the business domain and external service after the communication, because we don't know whether the request reached the final destination or not. So we have to somehow recover those problems, and for that we have Impotency Principle. And the idempotent function is the function that for the same arguments will return the same result whenever how many times you will call this function. So for our publishing issue, we want the function of publishing to be idempotent. How we could achieve this? By using some signature for the communication session. So if the signature exists, we understand that previous session was not closed successfully, so before we continue any mutation, we just need to verify current state, synchronize, and after that, make some mutation. So this case is pretty simple, but sometimes it happens that, for example, timeout error could happen not because the connection was broken, but because the external service started to go in outage on your particular one request. And you retried it for 5 times, and you see the timeout error, and what could you do? You don't know anything about the request, response, you just see this error, and that's it. So this case, again, we will cover in the interesting session later. So terminated in action is our problem here. And the last. Sometimes everything works okay, you send request, badam, and you receive the 500 or 502 or 504, and the next request is okay. So most of us pretty sure that will never happen again. You know, sometimes it happens, but and external service is down, and the worst thing is you continue bumping it with the request. And the problem here is that that's not a problem. The problem here is that when you continue bumping outaging service with the requests, you could end up with very, very weird issues because the state in the external service is broken so much that actually they could not recover it for a long period of time. But at the same time, you could even mutate that broken state. And if you want some example, read the postmortem of the Travis CI that was published a month ago when they wiped out whole database. And the most challenging issue was with users who continued to use the Travis CI after this wipe. So they had a lot of troubles with tokens, with the accessing the session. So this was a whole mess. So to actually cover this, we just need some switcher to at least manually switch off the communication when we see the outage. But of course, we love to automate, and if you want to automate, we need some solution, which we'll again cover in the interesting session later. So the last thing I got, apocalypse. So we covered what we have to focus, the most wanted issues, and why, you know, Murphy law. So the next question is, how we could cover it, and I suggest you to make a responsible choice for your future, and exactly to sign up the contract between your application and external service. Literally, I'm talking about design by contracts approach, which tells us we have to understand what we expect about each communication act, what we should guarantee, or what we should validate during this act of communication. And the last thing is what should maintain. The last thing is to verify that we only change something in our context and the problem will not go beyond. So we could actually implement it in Ruby. We don't see it pretty well. It doesn't matter. We just have one public method match that inside called two other methods. One will raise guarantee error, the other will raise expectation error. When? The guarantee error will happen if any predicate methods about guarantees will return false. So for example, the form of the response is not what you expect. And the second part is the expectations will fail if none of your expectations were matched. So for example, we could have the Twitter contract here, and we should guarantee that we have hash response, that inside this hash we will have non-empty JSON response body, and the expectation is just one example. We should actually cover their all expectation. We will have the whole file later. So the usage will be like that. You see it actually, or not? Okay, so the idea is we just initialize the Twitter contract object, call match, and yield a block inside which we actually communicate with external service, for our case, the Twitter. And the result will be passed through our guarantees and expectations. So the idea is to fail before we will even start to influence our business domain. So why this slide is here? Because I want to say how we could apply contracts to cover those strange issues that I told you before. For example, poor boundaries. Sometimes schema passed, but you have some business rules that could also restrict the continue of the flow. So you could actually introduce them as a guarantee rules inside this plain old Ruby contract. You don't need any Ruby gem, you just have this file in your application and that's it. Next thing is, for example, lost in translation. You could track inside the contract actual raw HTTP request and response, and at least attach it to the particular exception about guarantees or expectations, or even write some expectations or guarantees about the raw HTTP request and response. The next thing is, for example, terminated in action. This is the case when we had a timeout error 4 or 5 times. So for that case, contracts also could introduce here some HTTP request response sessions that will be added to meta of this contract, and you again will be able to debug it pretty fast. And for Apocalypse, we could actually add to the contract some statistics, and if some of those rules don't match for some period of time, or for example, you could express the critical request that you need to use for the external API. If they fail, you just switch off it automatically and everything will work fine. So, we're best enough to take a break. It's the picture of Ural Mountains where I was born. Not actually in this place, but somewhere around. Yeah. So take a breath. I need some water, I think. Let's continue. So we answered the how. We will use design by contracts. Next question is when actually apply them. And by when, I mean in which circumstances. So imagine that when you use some resource, it could be like you travel from point A to point B. And for example, you will just want to deliver one package from point A to point B once. So the only infrastructure that you need is the map and the route. So again, it's the same about the communication between your application and external service. So this type of communication is mostly manual. You maybe have some script to export the data, and most likely you will not introduce any code in your code base at all. Why I'm talking about this case? Because frequently from such stage we will go to the more intensive, and we will need our knowledge that we had a year ago. And to actually somehow express this knowledge, you could use contracts approach. Just in the plain text file, you could write the expectations, the guarantees, and variants, and you will remember where you made a mistake, and hey, it will help you to not to mess with it again. So when intensity grows, we need another infrastructure. It could be path. So for path, we have automated communication between application and external service, but most likely it will be manual. For example, it could be a quarter or annual financial reports, and as we know, financial data is sensitive, so we just run them by hand. What is the problem here is that most likely this communication, because it's not intensive, will be written in the one-day living code mindset. What does it mean? A manager comes to you and say, you know, we don't have much time, just smack some keys, and we just need to run it once or twice a year, and we will just start enough instances of your application, Amazon, and everything will be fine. Just don't care. Write it fast. But anyway, you introduce some external requirements inside your business domain. For example, you could connect to the same database, and that means that you could introduce issues. Even while you run the process manually, inside it automated, so you automatically could break up your system. So what are the solutions? The basic approach is fail fast. In any case, when you see the tip that here could be array or hash, just fail. There should be strict understanding what should follow. But we could go beyond the system level and introduce the contracts and use some business rules to, again, fail fast, but with a better understanding that later we will not touch the business domain if something unexpected happens. The next level infrastructure when intensity grows is the road. So for this type of communication, we have automated everything, and the requests are usual but not frequent. For example, let me tell you a story. We had a feedback form on our site which just sent the feedback to the CRM system. So everything worked okay, and at some point of time, there was a refactoring on the front side, there was a refactoring on the back side, and finally, we have totally tested backside that sometimes respond with validation error, and that's okay, because, fields should be validated. And front end that expect from us the error in particular form. And the backend just didn't return it with proper form, and frontend always thought that everything is okay. So user typed in his feedback. He said, you know, it's hard to use your service. I'm so upset. Could you help me, please? Send, press enter, and see the message. Don't be upset. We sent your feedback, while in reality we got validation error. Nobody see it because validation errors are not tracked, and nobody even knows that customer was sad, and how we could treat those issues. So the general problem is that we could lose track of those issues because they are not too frequent. They are not, you know, all the time happens, and we just could forget about it. And at the same time, they are autonomous, so they automatically could break your system. So the previous solutions will work, but you should introduce here the error tracking system like Airbreak or Honeybadger, just to aggregate the errors both system level and contract level. But the thing that is, for our case, we didn't have here the error, but we could actually calculate the statistics of particular rule matching. So for example, we could introduce inside the contract rule validation failure and track how many times we actually saw this error. And if we'll be able to see these statistics about front-end and back-end communication, we will be able to understand that all the time we see validation error. And that's it. Imagine, no. Try to answer. How many time it took for our case to fix this issue? Week. Month. Quarter. True. Yeah, so the manager came to us and said, you know, for a while I don't see any feedback from our users. It works so well that they have no feedback. You know, we were frustrated, we checked something, and that's it. That was the problem. It was fixed pretty fast, but we were not able to identify it without statistics. So the intensity of communication grows, and we need a highway. And at this time, we have autonomous and frequent communication. Imagine you have millions and millions of requests. For my case, I write a DHL integration, and we calculate cost of the shipping for each order of each customer. You know, if they want to to receive it with the DHL. So the problem was that at some point of time, DHL decided to add a field to the response, which was called warnings. And the API client that I used assumed that if you receive something with error code, for us it was warning error code. That means that the response is error. And the warnings that DHL actually sent was, you know, our calculation may be inaccurate. So for our case, it doesn't matter. So I just could use this tariff anyway. I have all the data about tariff anyway, just some additional fields with warnings. I just could ignore them. But I didn't know that I able to ignore them because I just saw that for sometimes I have errors for the order, and sometimes in a while I see that error just disappeared. How I could even understand what's the problem? So every time I start to fix it, I see the state of the particular parcel was changed, and damn it. So I could try to trace all the requests, but understand, I have millions of those requests, so it will be too much trace information and whole mess. So what solution we could use here? Of course, all previous tools are valid here, but for this case, we also have to introduce what I call sampling. So we could actually, for each rule that was matched and the unexpected behavior also, we should write down in some database the whole session, all the meta information, all states of all objects, just for one single communication. This will be we will call sample. And of course, we could not use this sampling for all requests, but if we have a hot switch that during the production running, we just hit the button, and we started to capturing those requests. Then we turn it off, and we have no impact on the system. But in our database, for each rule, we have a match that we could take out from production, and then introduce it in development, fix it, find the problem, and stuff like that. So, and this sample will also, if you use Sniffer, it could contain the raw data and lots of stuff. So at this point, actually, we see that beyond the plain old Ruby contracts, we could have so much stuff. So I've decided to create a tool for that, the toolbox, and I called it blood contracts. So for now, it's not officially released, but I already have the open source repository that I will share with you. And we plan to announce this tool in a week or two. And we have inside the plain old Ruby contracts behavior, we have whole statistics, we have sampling feature, the hot switch, so everything and much, much more. So we cover when. And we have a little time to get under microscope of the contracts. So they saw this picture earlier. Oh, sad. We see here that inside the plain old Ruby contracts have pretty simple logic. It just go through private methods that starts with guarantee, and this is a guarantee predicate. And the methods that start with expect are expect predicates. Don't try to remember it. I will also share the repository with the plain old Ruby contracts in the end. So, but remember that it's only for studying purposes. When you will introduce it in your system, verify everything, adjust to your system, and stuff like that. So, and we see the interesting thing is that every time we raise a guarantee error or expectation error, we actually raise it with metadata. So even if we'll catch this error using the air brake, we will have all the trace information that we need to actually fix this issue. And the example of the contract. So, so dark. So the guarantees we saw, they will look like that. So inside meta, I also add the response type, for example. For another guarantee, I will also add response body. So if I'll have, for example, JSON parse error, I will able to see what actual body was. So if you're not familiar, when you got the JSON parse error, we only have only one character that broke the JSON, and you are not able to understand what actually happened. And with this single line, you will be able to fix this issue pretty fast. And so the expectations are actually a list of all states that could happen with the communication. So that means that if none of them will match, we will have an error. Of course, it's the naive implementation, and in curious cases, we could discuss it after the speech. We could use some advanced tools here, but anyway, for the simple case, this will work. So we, again, extend the meta with all necessary data, and interesting point. We validate here that we have received the client error and server error, and we don't raise exception for that case because sometimes we could actually get the error message and show it to the user. Because for my case, for DHL, for example, they have pretty useful messages that will tell the customer what they should fix in the initial data, and that's it. So while we're talking about the successful communication, we don't validate just the code. We also should cover what fields do we have in the particular hash that we've decoded from JSON. That means that sometimes I could receive the dataset without ID or without favorites count from Twitter, and I could not process it inside my business domain because otherwise something will be broken, and again we'll end up with some issue that's hard to debug. So the usage will be, oh no, before we could also cover the blood contracts version of the contract. So I introduced simple DSL. So the contract now could fit inside one page. And we don't have to actually add something to meta because automatically blood contracts try to gather enough data, gather as much data as it could. For example, you could apply sniffer, and it automatically will record the session of the communication, and you will be able to access the raw data that you need. And also, there will be plenty of other features, but I want you to focus on the API call object. What is it? It's actually the abstraction they call round that will contain all the data about the communication. So is the input to the API client, is the real output of the API client, some additional meta, for example, about the how much time it took for the request, and plenty of other stuff. And all that is accessible inside your expectations. And of course, in case of failures, you will see all the data in your error tracking system. An example of usage, damn it, how dark it is. So the usage is pretty simple. With RB session, without any gems, we just use the plain old Ruby contract, Twitter contract, and the example of usage. Here we just run the response and see that JSON parse error unexpected token add. For my case, it's not interesting because XML is too short, but anyway, you will have the response body, and it works. Next thing is when the response is valid, we just don't break the flow, and everything works well. And the last thing is that expectation error when we've received the code 600. I'm not sure how we could actually believe such response. What does it mean, 600? Maybe that means that they will not continue work for an hour. And the example of the blood contracts usage, it's about how you could use samples and statistics. You just need to instantiate the contract, and you could use sampler inside this contract and load the particular rule or other filter, or you also could find all the samples that you have, extract their names, and then load the particular sample. And by sample, again, I mean the API call abstraction that contain all our data, and we could use it in our console, Rails console, or ERB session. And the statistics about the contracts usage, again, you could use some filters, but in total it will look like that. It's divided in periods. For our case, it's 12 hours periods. And we see actually how many of each rules were matched during the period. So that's pretty much it. It's simple, but if you export those data to Prometheus, you could add notifications, see the beautiful graphs in Grafana. So we also plan to add this to release of blood contracts too. So the last thing is the side effect of that we have the statistics about rule matching is that after your test suite was passed, you actually could take a look inside the statistics and understand which cases you actually didn't cover. So you could have the 100% lines code coverage, but at the same time you didn't cover some corner cases of the business domain behavior. And the rules matching statistics will show you. And it will also be available in the blood contracts. You just add the reporter, and it will fail tests if it will find that after the code change, there were rules that were not matched. So let's recap. Remember about the layout of our problem, and even if you don't mind about it, you have the request-response mapping layer and transportation layer, and all could fail. And if it fails, you should remember how to treat those issues. And remember that you don't have to treat them all the time. Just use the intensity strategy to use as little code as you could. And the final, use the design by contracts approach, not only to communication, but try it for designing your software. It's pretty interesting, and for me it was very insightful, so recommend. Thanks. So this is the link to the blood contracts gem, its current state. Again, in a week or two, follow our Evil Martians blog or my Twitter, and you will see the release that you could actually run in production. For now, we actually use blood contracts in production, but again, we want to pack it for everyone. That's it. I'm ready for your questions.
Thank you. All right. Right there. One question there. I'm not here. On the back. No, that way. Yeah.
Okay, thank you for your talk. It was fairly interesting. And I have a couple of questions for you. So there can be a case when your API is quite unstable and business logic allows it. So for business logic, it's everything valid. And your API, for example, Microsoft Azure API, and if we're talking about resource groups, for example, they can return some stuff, and the structure may be quite different. But for business logic, it's all valid. How can we use contracts when we have such unstable API?
Again, actually, it was created while I was made the integration with DHL, and they had the same issue, a whole bunch of different fields that could return or not. And it actually matches with the expectation abstraction. So you just need to write a proper amount of the expectations, and that's it. I have one more note here, is that you should apply to the contracts the same technique about refactoring as to any other code. So if you have a large contract, you just need to figure out what you could extract from there, and it will be part of your business domain. And you could write unit tests for it and stuff like that, use it somewhere in your business domain, but inside the contract, you just will call a particular function that will assume that the behavior between your systems was like what you expect. And anywhere when you don't want to raise an error, you could configure it. You could just don't raise it, but sample, for example, just in case when you need some debugging information. And that's it, nothing will be broken.
So we just introduce different cases in contracts.
Yeah, true.
Okay. Thank you. And second question, do you have a Martian stickers with you?
Yeah.
Awesome.
I will present you, because you asked a question, I could present you. So
okay,
come later. And
you can give it later. Thank you.
So
question over here.
Thank you for your talk. Quick question. You've discovered the design by contract while doing work on this API issue, or it was some previous research that was aha moment while doing?
There is a huge story about how I came to such solution, and the contract was just the abstraction that was fitted pretty well with the problem that I've tried to solve. So I don't know, it was just the insight that solved my issues, and I just decided to share it. I'm not sure, maybe even I didn't reach the existing tools that actually do the same. I don't know. If you have such idea, you could share, but for me, it was just, contracts was just the some insightful idea to use.
Okay, so it's a aha moment. Thank you.
Right there. Yeah, can you pass it?
Thank you for your talk, and I have two questions. The first one is, can you describe in a more clear way what the essential differences between guarantees and expectations in your slides?
Yeah, so guarantees actually, we could call something like preconditions and postconditions about the guarantees and expectations, different notation we have in different sources. So idea is that guarantees is some essential part that should always be valid for the communication. So it's just more like simple policy object or some usual thing. And the expectations are a bit different because we used to the validations that they should pass all the checks or most of it. And for expectation, we just try to find one of them that will match, because expectations is nothing more than our express of how we understand communication. So it's the ability to cover what you actually know about the communication. So
it's more about data, I mean.
Sorry?
I mean, it's more about data in the response. Or
yeah. Sometimes it's about data. Sometimes you could actually use in the expectations part of your business domain logic to validate that particular response will affect in the proper way on some part of your system, for example.
Okay, thanks. And the last question, can you describe what strategies we have in our applications between the third-party services? I mean, the back-off timeouts and stuff like that. Is it related to the contract API testing between application and third-party?
Actually, I don't understand what you're talking
I
about.
mean, if we have a third-party API call and something is broken on the other side, and we must maybe call our, do our call through timeout, maybe maybe put it on the other queue and call later.
I think I've got your question. So the idea is that sometimes we are, for particular APIs, we are able to verify that third-party service is actually alive. This is also could be written in contract, and it could break your mind because it will be another type of contract. So I understand your frustration, but it's it's some corner case because you're not always able to do that. Because for example, for DHL, I don't have such opportunity, because if I create something in DHL, a real carrier will go to the client, and so sometimes you only could assume something on the statistics, and that's it.
And the last question there.
Yes. Please, thank you first of all for your talk, most interesting and inspiring. I would like to ask you all personally, I've got some experience working with SOAP, let's call it protocol.
Yeah.
Well, for me, these contracts look a bit like SOAP protocol. So about plans for the future. As far as I see, for now it's more implemented on the client side. Do you plan on implementing it on server sides, and will there be, for example, some path URL which will provide some in some format contract, which is
totally true.
downloadable?
Yeah, we work in Evil Martians. It's some inside information. We're working under the extension to the OpenAPI initiative, because OpenAPI for now covers XML and JSON and any other formats, and we want to actually generate. We want to be able to generate contracts to penetrate your actually service and stuff like that. So yeah, we're working under that stuff.
Well, thank you very much, and we honestly won't tell anyone that you just a bit.
Okay.
Thank
Thank you, everyone. Let's thank again Sergey for his talk.